And you're up.
All right, welcome to the Vancouver Event-Driven Meetup, formerly known as the Domain-Driven Design CQRS and Event Sourcing Meetup, which was a mouthful. So thank you for renaming that. And this was an idea by the CEO of Event Store to rename the meetup. And it's become more of a virtual one with people collaborating all around the world. But certainly a lot of the event-driven stuff started in Vancouver, with Greg Young being here for a few years. So it's really kind of taken off as one of the hot spots of these types of approaches and architectures. And today we're happy to have Jamie Isaacs with us from, I believe it's California. And he's going to be talking about OAuth2 implementation in Golang, which is modeled with event modeling, and to see how all of this ties together, from requirements and ideas all the way through to implementation. So thank you, Jamie. Go ahead, I'll mute my mic and you can take over.
All right, thanks. Hi, I'm Jamie. We're going to cover GoAuth2 implementation in Go, and we're going to focus on process managers and how you would implement that. But first, what I'm going to do is give you an overview of the project, how I got to where, kind of from zero to where I got to today. And let me share my screen and I'll show you the project on GitHub, and then we'll go into a Miro board with the events and the event model. So this is the project. It's hosted on GitHub. It's open source, written entirely in Go. It uses an embedded event store called RangeDB that I wrote previously. If you're not familiar with OAuth, there's quite a few flows, and I'm not going to go into those just yet. What we're going to do is we're going to cover, I believe, resource owner password credentials, because it's one of the more simple flows. Let's see. Let me show you the Miro board. So what I did was I went to the RFC for OAuth to identify all of the different events that would happen in various flows. So there's like 4 different primary flows in OAuth. And let's see, if you haven't seen this board, the sticky notes will come in these different flavors. It'll be either a query in green, a command in blue, an event in orange, or a constraint in pink. And the constraint are business rules to apply to previous events to facilitate the execution of a command. The dependencies are going to be dashed. A happy path will be represented with a dark black line, and an error path will be a red line. These curly braces show you what a process is. So whoa, that wasn't what I wanted to do. Okay. So the kind of the entry point to an application would be to have a user being onboarded. So this was the first event that I put in the system. And a lot of things depend on user being onboarded. Same thing for a client application. A client application would need to be onboarded in the system for all of these accesses to be, I guess, to be granted, suppose. So if we look at resource owner password credentials, right over here, the goal for resource owner password credentials is to get an access token so that you can make calls to APIs or to gain access to resources. And the command for this one is to request an access token via the resource owner password credentials grant. And the happy path, if you follow the black lines, would be to having an access token being issued and a refresh token being issued. The refresh token is a different flow. If you don't, once someone logs in with their username and password, then the service can, without requesting their username and password, continue to retain access after the access token has expired. So there's a refresh token flow, and that's the whole point of process managers in an event-sourced application, is how do we make that refresh token kind of work in the system? Okay. But the problem I had was, if I just had this event storm, I didn't know how to turn it into code because I didn't know where these events should live. There wasn't a process to show me where to put them. And I came across Adam's website, Event Modeling, and this was the outcome. I took all of those events and commands and turned them into a process to show like what streams you would put these events. And these rows here, the resource owner, client application, and refresh token, represent an event stream. An event stream is the aggregate type, in this case, resource owner, and the ID of the user. That's the stream. If you put those two together, these are all of the events that live in that stream. And the same thing for client application. The aggregate ID for client application is the client ID. And for refresh token, the aggregate ID is the refresh token. That's just a UUID. I believe all of these IDs are UUIDs. So the problem I had was, if I'm going to give someone an access token as well as a refresh token, that's fine. I can put those in the resource owner stream. But when we want to take that refresh token and use it as an authorization, I don't necessarily have the user ID, and I didn't know where to put that. And that's where a process manager comes in. So a process manager either can look at, it can either look at a projection or be a projection itself and just listen to a stream of events and then emit commands. In this case, whenever a refresh token was issued event comes on the stream, this process manager picks it up. It's a token processor, and it issues a command to issue a refresh token to the user. And that puts it in the correct stream. The refresh token was issued to user. And I didn't, as of a couple of weeks ago, I didn't know how to do this. Last time we filmed it, last time we had this meeting, I didn't have this implemented, so I didn't know how to do it. And that's the whole purpose of this one. Are there any questions so far before I go into the code?
Yes, I have one question. On the top where you have little gears for the process manager, you have one arrow pointing backwards. Can we make another token processor instance further to the right for the second issue of the command? And that way all arrows keep moving forward. We know it's the same thing, just another instance of it. And that way we can follow the slice model for the implementation. So I can see that right now this is an example. Does that make sense?
Yeah, that came up with this big ball of mud up here of events, because I've got arrows going backwards. It became kind of a mess to maintain multiple instances, especially with this. This is the token processor, and there's lots of arrows pointing to it, and this really was hard to make sense of. When I had multiple versions, multiple copies of it, they weren't getting updated properly. So that was one of the problems I had. It seems like doing it this way can make it more explicit on
when it comes into play, right?
Right. Because like the flow is, here, let's go through the flow. You onboard a user, that's the command. Then you onboard a client application, and then you request an access token. That processor issues a refresh token. And then the next flow is the user, like maybe the client the access token is expired, and now they want to use that refresh token. So they're going to request an access token via a refresh token grant. And that has to go to this stream, the refresh token stream.
I think you're missing another read model in there, the dotted line, because one of the rules in event modeling is to not have an event touch command directly. So you have to say that there's a projection of that fact into something that is read by the user or or provides information to go along with the command. I think we touched upon this last time.
Yeah, I think Alex pointed that out last time and I deleted it, but I think that was a different board. So yeah, this you're saying this line right here that I just removed?
Yeah, it has to go to another green sticky that explains the view of that state. And then you can use some of that information inside the command if you wish.
You're talking about like this one right here? This is the correct way to do it?
Same pattern, but before, yeah. So refresh token was issued to user. That has a projection into some sort of a state. Not that far back. Just the one that you just added, that little refresh token, a little bit to the right. A little bit more. Yeah, that guy. Yeah, right there.
This one?
Yeah, this one, and you just added this, right? Oh, no, sorry.
No, it had been there.
Oh, sorry, it's that one there. I went too far. Yeah, exactly. So yeah, in there is a green sticky that is missing. It's either the same active refresh tokens or something else. that will provide the information to the subsequent command right next to it.
Okay. Okay. I'm not sure how to change it right now. Is this okay to move forward?
Well, you won't have a read model for it, right? So that's why if you just copy active refresh tokens as a placeholder and stick it, right in the middle, and then connect it through.
So this one goes up here?
Yeah, exactly.
I got you.
It's the same,
I got you.
It's the same pattern as always, right? So
I see.
event, view, command, processor, right? So it's always command, event, view, command, event, view, command, event, view. And that forces you to name, well, what does this event mean that it just happened?
Oh yeah, it does look like
it's there a date, right? Like, what does it mean?
Sure.
Like, okay, it's one of the things that I think what event storming does is it puts that explanation on the other side of the command, but we need to know that beforehand. I think it's a real missed opportunity to explain what a specific event in the timeline means in terms of the view of the state. If you put it past the command, it's too late. It doesn't really front load the information to make the command handler a pure function.
Okay. Okay, cool.
Because now you can use any information that read model in the subsequent command to glue things together.
Quick question then.
Go ahead.
That process up above this screen, if you scroll up a little bit, to me, that token processor feels like it's going to end up polling that active refresh tokens because it's not subscribed straight to the event.
That's correct.
It's putting the view in. Okay, that's correct. Cool.
Right. That is correct. In fact, those read models can be thought of as being part of the process, token processors or whatever processors you have.
Yeah.
And it's about making the information explicit because I can't stick that info into the processor itself. I guess I could, but it would complicate the model and get out of this cadence of being able to look at input, output, change state, and then what is my projection of the state or different views of the state. So we're trying to keep a very simple cadence to everything, and this is one of the ways that we do that. And I'm really hesitant to allow more complications added to this simplicity, because with simplicity you gain a lot by having something that's a little bit easier to explain to people. It's like, well, why do I have to make a read model? It's because everything else does. And if it's benign, fine, just copy paste. At the same time, it's going to help you get a cadence to the implementation, which we'll get into next. Sorry. Okay. I hope that's not too much of a distraction. I just wanted to be clear about why I set this sort of cadence up this way and the reasoning behind it. It's not just because it's not out of thin air. It's out of experience and that we create fewer snowflakes that are unique in our solutions. So we get a proper cadence with just a few patterns rather than a book of 50 patterns. We want to concentrate at this molecular level of the solution rather than try to have something at a little bit higher level patterns, since there will be a proliferation of many of them, and then it'll be harder to teach and harder to follow. I hope that makes sense.
Cool. Are there any more questions before I jump into the code? Because the implementation is kind of a mixture of those two ideas. It's not, the token processor doesn't depend on a projection. It in itself is the projection because it listens to, it subscribes to a stream of events.
Yeah, it could literally be a variable in your processor.
Yeah.
It really is independent of the implementation, but it helps explain how the information flows or what the view is of the information.
Yeah, I really like the context idea. That's really good.
Okay.
Well, right, enough. Let's keep going.
I'll jump into the code and let's just see how we would work with requesting an access token via resource owner password credentials, and then seeing this flow of how do we get this refresh token into the correct stream. Okay. And I've got this up on the right. Cool. Okay, so this is the test harness that I've written. On the right, you'll see the unit tests, and on the left, well, depending on what you call a unit test, I'm going to call it the tests, and on the left is the implementation. But right now, let's just focus on the right side. What we're going to do is we're going to test this refresh access token via resource owner password credentials grant. That was a mouthful. That's the ubiquitous language, so I can't change it. And we're going to test that the access and refresh tokens are issued. along with refresh token. All right, so we're going to see that the access and refresh tokens are issued. So what we want to happen is access token being issued, a refresh token being issued, as well as another refresh token being issued in the correct stream. Now the stream is the refresh token ID, right? Does that make sense? And then for these two, the ID is the user ID. That's the aggregate ID in this case. And for the refresh token was issued to user, that's going to be in the refresh token stream. I hope that makes sense. I know I kind of messed it up a little, but the structure is given, when, and then. Given we have these two events in the system, a user was onboarded and a client application was onboarded. When we execute request access token via this grant flow, we expect these three events to show up in the event store. Now, this test harness, this then section, knows how to find out where these events live. These two events live in the resource owner stream, and this one lives in the refresh token stream. So I don't want to get too much in the details about how then works. Like we can look through it, but it's not really part of what we're discussing here. This is just ensuring that this is the flow. And all of the tests in this project are designed like this. Given these events, when this command happens, then I expect these other events to show up in the event store. If you have any questions, feel free to jump in. Without that, I'm going to keep going. And what we can do is we can test this flow, just this one, and we can debug it. But first, I want to set a breakpoint in the dispatch method. Whenever the when section happens, it calls application dispatch. So that's how we're going to get to here whenever I start the debug. Okay. All right, so we step over, we've got the command. The command is request access token via resource owner password credentials grant. And the first thing we have to do is step through the pre-command handlers. And if we look real quick, there was this dotted line to represent how a command can successfully make it through to the aggregate to start processing. And I use something called a command authorization layer. It's a command pipeline. And effectively, each one of these aggregates, or I guess aggregates probably isn't the right term. Each one of these portions of the application have a responsibility to respond to commands and allow them through the system. I guess that's one way to say it. So that's what the pre-command handlers are. And up here, we just take a peek at how they're set up. Right now, there are two pre-command handlers. There's one for the resource owner and one for the client application. And what that will do, I'll show you what that looks like in a second. Okay, so back here. So we're going to go through each one of the pre-command handlers. And the first handler is the resource owner command authorization. Let's step into the handle method. I don't think it responds to this one, but we'll just take a peek at it. Okay. We're going to switch on the type, and it does not appear that it knows how to handle that type. It only knows about this resource owner command authorization object only knows about these three commands. So it's going to say, yes, you should continue. So it responds with true. The next pre-command handler is the client application command authorization. That is another mouthful. Let's step into the handle method on it. Let's move it over here so we can see where we are. I believe it does something with this. So we'll switch on the type. Yes, it knows how to handle authorization for this command. And what this one does is it goes and grabs a client application aggregate, checks to see that the client application is onboarded. It is in this case because we saw that event, which was client application was onboarded. Now we check to see if the client secret that was passed in on the command, in this case, the client secret was C389, and the client application secret is C389. So that'll pass through. So that's correct. And it'll say, yes, it should continue. If it wasn't, it would return false. Let's see, where was that one? If it was not if the client secret did not match, then it would emit an event saying it was rejected due to invalid client application credentials. But in this case, it returns true. So that means we've passed through this command pipeline. And when we're done with this presentation, we can talk about if that's even a good idea or not. I'm not really sure. It was the quickest way I could find to pass the tests. Okay, so now we've got the request access token via ROPC grant. That's the command type. We're back in the application dispatch method because we've passed the command handlers. Now it knows that this command is handled with the resource owner aggregate. So that's what's going to happen. We go to the event store, get all of the events by the stream, and we know the stream because we have this method to get the event stream by the command. Okay, so now we've got all of the events. The resource owner needs a token generator and a clock as dependencies, so we inject those in. And we go to the constructor on the resource owner object. Now this is the aggregate. This is the resource owner aggregate. It accepts it accepts events. In this case, they're called records because they have the container, not just the event. And I'll show you what that looks like in a second. It takes a token generator and a clock, right? We got those. Now we're gonna go through each record. So we had user was onboarded, that should show up. So the first record we get off is, here, let's just step one more through. Yep, that user was onboarded. We can step into the apply method to see how that works. So we switch on the type, it was user was onboarded, and we just set is onboarded is true. We set the username and the password hash so that we can work with those later. I think that's the only event so far, and that was it. Okay, now we've got the aggregate. Now we're gonna call the handle method. The handle method switches on the type. We've got this command, that's correct. Now we check, is it onboarded? Well, that was true a second ago, and yep, still true. Is the password valid? We take the password from the command and just pass it into this method to verify the hash is correct, and that's true. So everything was good. We're in the happy path. We get a token from the generator, and then we emit these two events. But this isn't enough, right? We expect these two events to be emitted. But we also expect this one to be emitted. How do we do that? Because we can't emit it here because this aggregate only knows about the resource owner stream. It can't emit events for other streams, at least in this implementation. And I'm not sure if there's a way you could do that. I don't think you would want to. Okay, so we emit those two events. Okay, Okay. Now,
so what you could do is you could pass it off to another processor to do that, to kick off the second one. So you could have a to-do list. Hey, by the way, someone else issued this other thing for this other aggregate. That's how we glue streams together through these read models and other processors. Just a thought.
Okay.
Continue.
Cool. So the aggregate handles the commands, and what happens in the aggregate is it has this pending events, right? So whenever you emit, I guess it's right here. So when you emit, it just attaches all of the events to pending events. And back in the application, we save the pending events, and the save pending events takes a pending eventer. Basically, here, we'll just dive into it. That might make more sense. There's a method called get pending events, and then it saves it from here. So it goes and grabs all of the events that were emitted from the aggregate. In this case, those pending events are access token was issued and refresh token was issued, okay? And we go to the store and we save. Now here's kind of where the magic happens with the process manager. Now, we're trying to get this refresh token was issued to be emitted in the system. And one way to do that is to have the process manager, have this process manager subscribe to all events saved to the event store. Let me just show you that first. So remember, we're right here. And I'm going to go up and show you how the process manager for the token process manager subscribes. So whenever we create an application with this constructor, we set up the pre-command handlers, and then we set up all of these process managers. In this case, we go to the store and we subscribe. We tell it, here's some subscribers to events, and this is a refresh token processor. And we have to pass in a callback method to dispatch any commands that may get dispatched. So refresh token, let's go back to where we were. I forgot to mention that earlier, so I had to go backwards. So let's dive into the save method and see how we get to that code path, if we can even get there. I think we can. So the save method, right, so we'll go into this save, there we go. Now we're in the save event. So we've got the event that came in is access token was issued to user. We can probably skip to the next one. I think that might be better because the process manager doesn't respond to access token was issued. So we're gonna skip to the next one. Okay, access token was issued, let's skip again. There we go. Now let's dive in. Refresh token was issued to user. So now it saved the first event, which is the access token was issued, and now it's saving the refresh token was issued. Okay. Right now we're in the code for the RangeDB project, so we're not gonna be too specific about how that works. What we're going to do is come down here to notify subscribers. That's what we care about. Now it's going to, once the event has been saved to disk, it will notify any subscribers that, hey, this event was emitted. And what this does is it steps through each of the subscribers, and S, I believe, has a couple of subscribers. It's got a refresh token process manager and an authorization code process manager. We're only interested in the first one, which is, which subscriber are we on right now? Refresh token process manager. There we go. Now we step into that one. Okay, now we're in the refresh token process manager, and it's basically a projection. It knows how to receive a set of events. In this case, the event that came in was, let's see, we'll switch on the type. Refresh token was issued to user via ROPC grant. That's this event. And what we want to do is make this event show up in the system, but we can't just emit it. We need to issue a command from the process manager. Okay, so we've got that event. And now we call the command dispatcher and say, hey, issue refresh token to user. And if you remember, that's this. Okay, so we received refresh token was issued to user via ROPC grant, and then we issue refresh token to user. And what that will do is emit an event refresh token was issued to user. Okay, so let's see how that works. Let's dive into the command dispatcher. Dive in. Okay, let's skip over the pre-command handlers. Okay. Issue refresh token to user. Okay, I'm curious what's the logic for issuing a refresh token to user? Let's go take a peek. Okay. Oh, we wanted to go to the apply method. We can just get here. Or the handle method rather. Handle. Issue refresh token to user. Well, it just emits it. That's it. That's the magic. It's just a state flow diagram to emit this event. And that's how this system implements process managers. Okay. And then the rest of it is just finishing up, saving the event. Okay. Notifying each group. One thing you got to be careful with is if you can make a feedback loop with this, is if your process manager emits an event that another process manager receives and emits an event that this process manager receives and emits, and you can go in a cycle. And it's kind of a risky proposition, but that's the code. That's the primary thing I wanted to show today. Do you have any questions on the code specifically, or how it was implemented, or basically anything? Just shoot.
I have a question. Could you go back to your diagram? And this, forgive me if I missed some of the things that were said by Adam and yourself, Jamie. So your process manager, the token processor that you have here at the top, yep. In the code, it looks like that, and I think you mentioned this as well, that was your projection. The process manager itself was projecting that event. In the model the diagram here, Adam earlier was saying, just make sure that you have your read model, the green sticky, the projection as a called out sticky. I wonder, so it's kind of like in the code, your processor was actually that green sticky.
It was like in the code, these two are the same thing. Well,
yeah. So I wonder, you know, is that necessarily a bad thing? You know, Adam, maybe you could talk to it. Like, how would you expect to implement that in code?
It's not a bad thing at all. And one of the things about event modeling is not to glue it to the implementation. However, when people are, I don't know where to start. They don't have this idea about implementation. It's a great way to do it. So if I was ignorant about OAuth2 and I looked at the event model, I would store some sort of a read model, and I would have something stupid that maybe runs every second or half second that uses that as a to-do list to then carry on and do things forward. Later on, I would look at, oh, well, this thing doesn't scale. I can't have this running every half second. There's going to be really big batch jobs of this. It's going to have a really irregular heartbeat, if you will, toward the way the service is done. And that's when I will short circuit. It's like, okay, I can't stop and wait for this process to pick it up half a second later on each half a second. I'm going to have some sort of a reactive model where this, as soon as it's raised, it's going to just maybe do an in-memory, table, what's it called, array or something, slice, if you will, of these things that this continuous active queue is going to then just spit out commands. And so a good example of that was when we were implementing a bad word checker for a messaging system. It looked like, oh, send message to another user, and then the event is message sent, and maybe there's one command in between called clean up message from bad words, spam, whatever. That is a 12-step process. You have to tokenize the message. You have to put a dictionary of different languages, like what's in English doesn't match with what's in Chinese. So you have all this like linguistic stuff going on. So there's tokenization, then there's the different changes to the words in terms of if they're plural, past tense, and all these other things among grammar. So these green stickies actually were there, even though there was nothing ever stuck on a disk as an event or a read model. Those events and read models were apparent in really large variables. For example, an entire map of words or dictionaries for a lexicon for some language. And so this is where the event model really is looking at state changes and state view. And just because the implementation doesn't put it on disk doesn't mean they don't exist as concepts. And you certainly can have a number of different variables as they change to be green stickies, especially when they're non-trivial and they actually have the core view of some information throughout this whole thing. So you'll end up having implementations that absolutely do not reflect what you see in terms of an event model at the very basic understanding, such as these are different read models that exist as tables in a database. No, I can have an entire swim lane dedicated to a very large variable that's used in some processing in my specific domain, because it's important to visualize that and say, hey, just because we're doing stuff in memory in our domain because of the SLAs that we need to meet doesn't mean that we can't treat state differently. We need to be able to communicate the state just as effectively as if we're talking about a dumb database application. It has to be done on the same level. What's interesting with traditional, just as a side note, with traditional stuff, I forget who it was that I was talking to. I think it was Jeff Doolittle from Portland. And he says that when we throw away events from being stored by doing traditional applications, our event store is actually the human mind. So he says, add a swim lane for events. That's the human mind. And you capture all your UX, UI. It's just kind of cool. But that's how independent the event model is from implementation. Yet it can be directly applicable as a starting point. And then you start to move that change of state and state view into swim lanes that start to really reflect what your system is made of. And it can be like, for that example, with a message processor for looking for bad words and spam, etc. That was a series of variables that were being used in certain core procedures to say, this is what happens. And hey, business, this is why this is not the cost of one slice of work. We have these core transformations to do. And it actually is 12 slices of workflow that we need to implement to make sure that these specific messages do not contain bad words, etc. It's not something I can just spend another day on like all the other slices in our work, right? So this is where looking at state transitions and state view is the granularity that we need for estimates to be correct and for our velocity to be calculated correctly based on the complexity that we want to, that's necessary to do the work that needs to be done with information in our system. So I hope that's a really long answer, but I hope it gets to it. And it would be neat to see a couple of alternate implementations of the OAuth thing where we're being a little bit more pedantic or purist about doing things this way, and see that it kind of craps out in terms of SLAs, and then how we move from that to be the starting base of getting the information correct, and then start to optimize by moving some of those things out of actual storage and moving them into maybe temporary variables or whatever you may have, and how that's done. So it would be a really cool exercise.
Yeah. So thank you for illustrating it. It doesn't need to be that dogmatic when you're doing the model. So Jamie, let me ask you a quick follow-up. With the were there any other projections? I think it was refresh tokens. Was that it? User refresh tokens was the green projection sticky. Does an implementation of that projection exist anywhere else outside of that process manager in what you've written right now? Like, would that projection be duplicated effectively? Would you be doing the same thing in the process manager and outside of that? Is that necessarily a bad thing? Probably not.
Probably not. The thing is, this application is basically single threaded, right? Whenever the command comes in, all these other things happen in order. Now, it doesn't have to be that way. For OAuth, it might be important to have that kind of consistency, but say the refresh token, that's not super important for that event to show up yet, because they're not going to do that flow for 3 hours or however many hours it is. So you could break off that process manager into a separate thing that just maybe a Lambda, I don't know, however you want to do it, and the whole architecture would stay the same. It just wouldn't subscribe whenever you're creating the application. That would be taken out, and then you would use WebSockets or Atom, however, whatever event store you're using, if you're going to stream through the XML or JSON or whatever it is. If you want, I can show you an example of this working. Well, I guess it technically is working if you want to see it.
Yeah, no, that was good. Thank you. You guys answered my question.
But as far as other projections, I think there's an email to user ID projection. Whenever a command comes in, you don't necessarily know your user ID like in the system, but you know your email address. And you needed a projection to turn email address into user ID. So that's in there, and a couple of things use it. But other than that, there's only 2 process managers, one for authorization code. There's a grant flow where, depending on how much trust you give an application, you can give it a code, and then that code can be used to get an access token. Maybe you don't want your user ID getting into some application. Like resource owner password credentials is one of the last ones you should use, because you shouldn't be giving an application access to someone's username and password. It's just not a good idea. And that's where something like authorization code would work. They log in directly to the authorization server. That server gives them a token. They pass that token to this app. This app goes and gets an access token from that token. But I needed a way to turn that access token into its own stream. So those are the only 2 process managers in this project so far. It's completely not finished. I don't expect it to be done anytime soon. I'm just playing around with how to event source something. Does that answer your question? Does that help?
Yeah, absolutely. Thank you.
Cool. Did someone else have a question they were about to ask?
Yeah, it was more of a reminder. You had your process manager hooked up off the command handler, right? There's a second command handler on
it. The process manager is created and subscribed to the event store inside the app.
Okay, so which event was it subscribing to? Sorry, That's the bit I'd forgotten.
The process manager for refresh token was subscribing. There's two events and they're named pretty similar. Let me show you. It's probably easier to see it on the Miro board. It subscribes to this event. Refresh token was issued to user via ROPC grant, right? And whenever it receives this event, it says issue refresh token to user, but it issues one with a slightly different name. Refresh token was issued to user. We don't necessarily care what type it came in on. Maybe that's a property on this event. I haven't added that because I don't have any need for it just yet. I think with the way Adam's doing event modeling now is you'll have, you'll show which fields are on the events, which could be super helpful. In this case, I was just working with the names of events. Does that answer your question?
Yeah, it does. Thanks. Yeah.
I also add example data a lot of times now, just because the information completeness is so important. So not alone just the field types and the fields iterated on there, but I want example data in there. And sometimes I will forego saying user ID or something like that with the actual username. And that's another little differentiator between event modeling and something like UML, where you'll have IDs sifting around, confusing people. When I show someone on the business side what this thing does, I'm using real data that still shows data completeness and where data comes from and where it goes to. But I definitely make sure that, again, away from the implementation, I don't want user ID sitting there. I want jsmith at AOL or whatever, and things like that. So these are the skills that you'll kind of pick up. And as you get feedback from working with various different roles in an organization, where you'll make sure that the goals of event modeling are met, yet the data that you're presenting in there helps the most amount of people, which means being very cognizant of when you're alienating someone and when you're starting to get technical things in the way of what the goal of the whole system is. Does that make sense?
Cool. Well, actually, let me show you the flow really quick on how you can use this right now. And maybe that'll help solidify if you're still kind of not following too closely. So if you go to this project, there is a Docker image that you can run locally. And I'm going to just show you that real quick. Do that. Let's see. Docker run. Now 8080 is what the OAuth application listens on, but there's also an embedded event store that you can access. 8081, 81. And if you go to, this is the embedded event store. And when this project, at least right now when you run it, it starts off with these 4 events in the system. It onboards a user, it gives them an admin role, and then it allows them to onboard client applications, so that when you go over here, a client application was onboarded. These are the seed events for the whole system to start working. Without having a UI, I needed some way to test the system out. And when you start it up, it gives you some example commands that will work. And for resource owner password credentials, you can attempt to get an access token this way. And what this will do is it'll pass in the client ID and client secret. The client ID is effectively that number, right? And the client secret is C1E, right? Okay, the password is the grant type. Here's the username and password for that user, and then the scope. So let's see what that looks like. So whenever I run this, I expect 2 events to show up on the resource owner stream. Oops. Probably should have just copied this. And it gave me back an access token and tells me that it expires at this time. And then there's a refresh token if I want it. So actually this would, this new implementation, there's going to be 3 events, right? We wanted an access token, a refresh token, and then another refresh token event. So if I refresh this page, there's the extra events. There's the access token was issued, refresh token was issued. And if we go back to the list of aggregates, there's a refresh token stream and refresh token was issued to user. That's pretty cool. Okay, does that make sense? I know it's kind of contrived and it's just a simple way to make sure that I'm writing code speaking the language of the domain. And then the HTTP layer is just glue, right? All I'm doing is just calling the command to, hey, execute ROPC grant, execute or dispatch this command, which is request access token via ROPC, request access token via refresh token, whatever the different flows are. And then it makes it pretty trivial to build out the rest of the application. When I spent 90% of my time working with the domain, using the domain language, making all of the functionality and features work. And then the HTTP layer was just simple. Like I didn't have to spend much time with it. I wrote a few tests, and you can go see those if you're curious how to test in Go, how to test API endpoints. But that's it. If there's no more questions, we can stop the recording and then have more informal discussion if you'd like.
Well, it would be nice to have the recording still of the informal discussion and
Okay.
just snip it out, and you can use it if you want. Sometimes, you know, I did the podcast for a number of years, and after we finished with the guest, the really good stuff happened after we pressed stop recording. So I just said, no, we're done. Right. It stopped, and we got the best stuff after.
Sometimes not having it being recorded can help
just
drive
don't
those
tell
good
anyone.
conversations.
Like, okay, we're gonna clip this out. Official recording done. It's off the record. You can actually do it legitimately and say, hey, you said some cool stuff. Do you mind if we put it as part of the thing? And you definitely say that it's off the record. And then if someone wants to, if something cool does come up, it's just nice for the host to be able to ask that person of like, hey, do you mind if we include this? So yeah, it's off the record for now officially, unless all parties agree. Okay. Otherwise.
Well, this project was kind of born out of Alex challenging me to do this, because I wanted to build an OAuth server just to start building side projects and maybe have something to share with the company I was working with. And then it was just a challenge. Hey, why can't you do this with event sourcing? And so I started, and there are plenty of things that I do not like about this implementation, but there are some things that I really love, like specifically the tests. I just love how they're organized, and I don't know. It just makes sense to me. Given these events, when this command happens, these other events are going to be emitted, and it just makes it really nice. Versus having like state, given the state, when I call this method, here's some more state, what can happen is it's hard, if you don't organize your code properly, you start writing spies or mocks that assume the implementation in the test, and that's the type kind of coupling that I don't really like. What's nice about this event, the event structure in the tests, is I don't have to implement it with event sourcing. I can implement it any way I want. I could have done a regular CRUD application and just also have these domain events get spit out, and the test would still work. So but there's definitely things I don't like about the implementation. So if you want to talk about what you like or what you don't like, let's do it.
Well, I don't know. I mean, I did a process manager recently in Aggregate, and functionally, it's doing exactly the same thing. Subscribe to the event store, load some data if needed, do stuff, spit out command, sorry. And yeah, it's just almost so easy, which is why I was kind of curious to see how you approach it, if it's going to be any different.
When I first learned about CQRS and event sourcing, I was told that process managers could spit out events, but that really doesn't make a lot of sense. You want it to spit out a command, because if it spits out an event, then it's tied too closely with the event store.
Right. I have a question, and I'm probably going back to the HTTP as a protocol, whatever. Like, do you halt the request until that event that is supposed to happen after the process manager speed up the command? So how you deal with that?
So are you asking whenever the HTTP, the request comes in?
Yes.
And I know that the grant type is ROP or password, which is ROPC.
Mm-hmm.
How do I dispatch this command and then determine whether it succeeded or not? Is that what the question is?
Yeah, well, the command goes, you have a process manager there, right? So you depends on multiple events to happen to then create a command, to then create an event, and that's where you have to go to the GUI and say, here we go, right. I can show you like that event happened. So do you stop the connection, halt the connection, and listen to that event. And then when that happens is when you respond to that request?
Yeah, that's a good question. I can just show you in the code. It'd probably be the easiest way. Effectively, when you dispatch the command, any events that are emitted directly from that command come back. So in this implementation, it's kind of synchronous in that way, which you kind of need for OAuth. I didn't want to have this saga pattern where you fire off this thing and then wait and have this timeout. That felt wrong to me. Now, given that Go is a strongly typed language, I can show you some of the unfortunate side effects of doing it this way. So what you asked is an excellent question. I wanted to discuss it, but I thought it might have been a little too advanced for this purpose. But let's do it.
Yeah, for me, which problem, the younger one here, like since I never learned this first, I'm always going back to what I know and how can I apply, how can I move from what I know to these type of models? And this is the type of questions that I always get caught up with. And unfortunately, every time I pick like a project, this is what I want to figure out and I get kind of stuck on it. So yeah.
All right, so I'm gonna go look in the application and see where it gets dispatched. Okay. So this is going to force me to show you the test as well, just to give you better context. Issues access token and refresh token from refresh. Nope, that's not the one we want. So the token endpoint, client credentials, ROPC grant. Okay, so we have a test case that has client application and user onboarded. So we go to the event store, we onboard client application and user. We set up more dependencies, the token generator, and now we've got this OAuth2 app. And this thing can dispatch commands. We take that app and we inject it into this web application. So there's two apps. There's a OAuth2 app, and then there's a web application. The web application is what we're worried about right now, and that's what we're going to be testing against. This app has a serve HTTP method in Go, and this is a way so I don't have to spin up the web server to verify that the request and response work. So issuing an access and refresh token. Let's see. The expected body, so we expect whenever we make a request to the /token, do I have that up here? So when you curl localhost /token and you pass in all these parameters, the parameters are here. So grant type, username, password, etc. We pass those in using a forum URL encoded. We expect the response to have an access token that expires. We expect the correct to give us a token back. Okay. And what I can do is I can step through. Let's just do this. Debug. So let's just go. Okay, there we go. Let's skip that. Okay, now we go. So we're testing, we make a request to the /token endpoint. Okay, serve HTTP. I don't know if that's going to do what I want it to do. I want it to stop on handle. Where is the /token? Sorry if I'm flying around looking for this method. There we go. Let's do it there. Okay. So we got the client ID and secret that came through. We parsed the form. The grant type is of password, and then we're going to handle ROPC grant. Okay, so now this is where you were asking, like, what happens whenever you issue this command? Okay, we get more stuff. Now, this is kind of a mouthful here. So what we're going to do is we're going to go to the OAuth2 app and dispatch the command. The command is request access token via ROPC grant. And then we just pass in those values that we got from the forum post. And then what happens is dispatch returns a slice of events, and I cast that slice to this object called save events, and save events has contains and get. We'll just ignore that for right now. So now we've got this events, and what we're going to do is we're going to check, does it contain an access token? Does it not contain access token was issued? If it does not, then we're going to write the invalid grant response. And we'll do a specific one if it was due to an invalid client application credentials. we'll write an invalid client response or an invalid grant response. And those are details that are specific to OAuth. If you look at the, where do I have that? If you look in here, it'll tell you how you're supposed to respond, whether that's invalid client or invalid grant. That's the determination there. So this is kind of a messy way of satisfying those specifics. And there are tests that test these paths because at least all of these lines are covered from what I can remember. Anyways, now that we know that, yes, when we dispatched the command, there was an access token in there, then we go and get the refresh token was issued. If there wasn't a refresh token returned, because in OAuth, it's optional whether you give a refresh token. I know it's kind of, it's not how I would implement an authorization server, but it's what everyone's using. So that's what we got. The syntax is kind of strange because I have to go get that event and then cast it to that type. It'd be nice if there was some magic in the language to make this work, but unfortunately there's not. But now I can get things off of this event. So if I want to, that event has scope, client ID, refresh token, etc. Does that answer your question?
Well, let me tell you what I understood. So, because this seems to be synchronous, everything, right? This is not going to...
At least for the access token. Now, your question was about the process manager, I think. And to satisfy this portion, we don't, that's eventually consistent. So that event could be emitted several hours from now.
Right.
And if it was required, then that would be a problem. To have a command, in order to know whether the command passed, some process manager would have to put an event somewhere else. That would be a problem. So my solution was to, well, just to have the access token and refresh token put on the same stream so that we can at least know what happened with the user and still take action to determine whether it's successful or not. And then let something else put the events in the correct stream. Does that help answer?
I have one more thing to add to that. And this is something that I've done for inline, like everything has to be part of the same thread. The entire CQRS cycle can be in a single web request, right? A lot of times. And if you don't want, so one of the, and I think this is my fault for really trying to make event modeling really approachable, the idea of a process manager to always be an async thing that you don't have to worry about, etc. When it comes to implementation, there is nothing saying that has to be the case. And an actual simpler implementation is, let's say you have some read models that are getting updated with some events getting emitted. If you have a mechanism like here where you have a subscription model and method is called on a particular read model, when the read model finishes updating its data, the last step that a read model can do is kick off a process manager. So the implementation is organized so that the process manager has its own logic to deal with that, but it synchronously has a method call to go kick off whatever you traditionally would have as a kickoff via an event. If you think about, event storming type of thoughts, that you have events directly going there. You first update the read model, the to-do list that acts like that read model that acts as a to-do list for some things. After it's updated everything, just synchronously call whatever process manager looks at that read model. And that way you get your synchronous immediate satisfaction that things are getting done as soon as possible when the relevant information has made it to where it's supposed to live. Does that make sense?
Yep. Is that updated in the latest version in GitHub, right, Jamie?
The code that I've showed is up on GitHub.
Got it. Okay.
So every time there's a commit, it kicks off, it runs test in Travis, it sends code coverage to code climate, and it also kicks off a Docker Hub rebuilding the image. So you can always get the latest code.
Okay.
And yeah, if you have any suggestions on how to change it, I'm happy to take a look at a PR. Or if you just want to send me a message and say, hey, try it this way, I can probably try it that way if you're not familiar with Go.
Yeah, I'm now moving into Go, but I'm coming from Elixir for a few years. So,
Yeah, I don't know Go either. Two things I noticed in Go which were really interesting was that string format where you're extracting values from the string in the for the body. That was pretty neat piece of code. But I had a question on top of just the observation was, the whole apply situation where you take an event off essentially an array, slicing, I think you said it was, and you've got to somehow cast it back to the actual event, right? I've never found a pattern which basically doesn't involve a massive switch on a bit of reflection. I don't know if anyone's ever found any languages or approaches to, get that nicely strongly typed or something.
In Go, if
Compiler help.
you, there's a nice way, the language just happens to know if, I don't know if I have an example, but there's a type switch parameter, and then you can check, there's a second parameter returned, and typically in Go, you'll say okay, and then you have an if statement. If okay, then you can start calling things normal. I probably didn't explain that very well, but
no,
it does have,
like
it does have
type
some
of the thing, switch on that. Yeah. That's cool.
But it's an unfortunate part of a strongly typed language is dealing with these events. But if it was a dynamic language, then it'd be a lot simpler. The drawback is now maybe you're working with strings, and I am not a fan of using strings to represent anything in the domain because that makes it hard to refactor. If I want to change the name of something and then there's a bunch of strings everywhere that have that same name, how do I know that that's the right place in the code to change? And that's not very fun to be. But I think the trade-offs of the pains of being a statically typed language are far overshadowed by the tooling in Go. Basically, all I do is I have a class with the commands and a class with the events, and then I use Go generate to create all of the extra stuff that I don't really care about, like the methods to make it implement the interface of returning the event ID or the aggregate ID or the aggregate type, or all those things are just kind of handled for me, which is nice.
Yeah.
Any other questions about process managers or this Go implementation or OAuth in general?
I daren't ask questions about OAuth. The rabbit holes get deep.
Yeah. It was a necessary evil. I think as long as you have JWT or Passetto tokens for your access tokens, then you don't have to worry about the OAuth server once you get your access token. I don't like the fact that OAuth has a single endpoint that then handles multiple grant flows. I don't know why you just didn't have separate endpoints for each one of those flows. That's how I would have built it. But it's a pretty established pattern. Like there's different flows that you use for different application styles, whether you have a mobile application, a website, or a straight JavaScript in-browser application. So I think they solved a lot of security issues by restricting it. If you have a better authentication server style, I'm more than happy to try to pivot to that. But for now, it seemed like a pretty challenging project to work on. Thanks, Alex. You created so much pain, but I think it was worth it because I learned a lot more about CQRS, event sourcing, and event modeling.
Are you trying to take the project to production ready, which I would love to see that happen, to be honest?
This project, it's close. It needs a UI. It needs a couple of extra flows in there, and then some hardening, maybe some stress testing on it. Okay. But so far, this project is making the event store that I built more solid. Like I fixed a deadlock issue with the process manager. Whenever the process manager was subscribing to events, the notifying subscribers happened before I released the lock. So if you can imagine, like whenever an event goes into the store and then it notifies subscribers and then that kicks off another command that then tries to save events. Well, I had the releasing of the lock in the wrong spot. So I had to fix that. And so it's just this project is making the other project more stable. Every commit. I fixed 2 or 3 of these kind of issues that are never going to come up again, which is great. I'm by no means trying to compete with any other event store out there, whether that's the TM event store or the other 2 that are out there. It was a project that was born out of a proof of concept at a previous company, and we open sourced it.
Nice. This is like aside, Jimmy, in terms of like, I'm trying to learn a lot from your project. Honestly, it's really good. That is so simple in Go, force you to do things like explicit right there, like no introspection, how you say it, reflection. The same with the event model. Are you interested in documenting a little bit of how to get to your solution for people like me that are starting like from zero and honestly want to see like a path that I could take that would guide me through the steps of, okay, here you think about this stuff even in terms of the event store, and then you move into all this concept all together one by one.
I don't know how to answer. If you look at all of the commits, like I started this project a few weeks ago, or at least I started committing from the beginning. If you go back and look, I can just show you real quick.
As an exercise, what you could do is stick in some example data into the event model. Here it is. And then just have Jamie look at it and see if it makes sense.
Yeah, 20 days ago, I started the initial scaffolding, and you can see how the code kind of has evolved. It started with something very simple, like asserting that true is returned from this initial method, which was true. Mm-hmm. And got all of the Travis CI built up, got the licensing in there, got everything installed, and then slowly started adding things like added Docker. So if you're curious how to go from zero to this project, it's pretty clearly described.
Okay, this is what I'm looking at. Like if you're doing this already, look, I'm really thankful that you're doing that. Yeah, okay, then let me go through every single commit then, and probably, I don't know, I can lean on you, me trying to write a blog post about your code and see it from my perspective and see, where I'm lack of understanding and stuff like that. You could, if you could just help me out a little bit to double check what I'm writing, I guess.
Sure.
But yes, that's really good.
Yeah, I'm on the Slack, and you can reach me there.
Nice.
Yeah, luckily, well, I don't know how lucky it was, but the company I was working for had a layoff, and so I started working on this project, and that's kind of what happened over the past couple of weeks. And yeah, I won't have as much time because now I'm working for another company, so I'll do what I can.
It's a good thing. Bad problems to have.
Cool.
Nice.
Any more questions you want to talk about?
I found that really cool. It's very interesting seeing your perspective of it.
Yeah, I think even reading your code and the way you did it, it helped you a lot to understand the diagrams. You get to the point that you don't even need the diagram, so you need to say it's kind of like, okay, go here, and like most of what I noticed, like most of the code is kind of like simple programming, like they destruct and put it here. Like because I'm using Ori, which is kind of like popular in Go right now, but I got into the code. It's like I don't understand anything here. Like a lot of function calls, but without any meaning behind it, more than the person who wrote it. So like reading your implementation actually teach me a lot of OAuth2 itself. And yeah, and now you like linking it to the RFC also teach me how to read those documentation and mimic with the implementation, which is, for me as a young engineer, like that's really, really valuable.
Yeah, there's a better Go project for OAuth2. I referenced it a few times whenever I was building this, just to understand OAuth a little bit better. So because that RFC is really hard to consume. I've worked for 2 different companies and built OAuth servers using that, and I still don't know it all. It's so complex. So if you search Go OAuth server, there's another one out there that has an existing implementation. It's not event sourced, but it's pretty good. And if that's something you want to look at, I'd recommend it.
One more question, time allowing. Do you want to show us your then handler? It's always a fun piece of code to look at in that framework.
The which one?
You know your test framework. You've written something behind given when then to event source, right? My version of that, the then handler is less than pretty. I'll put it like that.
Yeah, let's look at that. Now it grew. The original test didn't use this structure. I wonder if I can see them. wonder if this one had a regular test. Let's see. I guess it would be underscore test. Private test, okay. Yeah, so the original test, that's the token endpoint. I don't have it off the top of my head, but if you look back through the commits, I'm pretty sure there's some that did not have this. But your question was, how does the BDD stuff work? There we go. Right. Stop that. Cool. I want to find one that's pretty simple because that has dependencies that isn't very helpful to see. Onboarding a user, this is the most simple one. And we'll do this one and then we'll do the next one. So for t.run, if you have a test, you need to have this callback function t star testing. And that's what I'm replacing here, right there. Actually, this isn't a very good one because this has a different then. Let's look at this one. So say they try to onboard a user, but that user already exists. So that's a good one to test for. So this GoAuth test case, let me move this to the right. Okay. So this first method returns a BDD test case. And all of this thing does is sets up the dependencies for the OAuth2 application. It creates an event store. It sets up any options you pass in using the functional style. And then it creates the application. This is what has the dispatch method. And what it returns is this new BDD test case. And to get to your question, this is what you're asking about. What is this thing? It's got the given, it's got the when, and it's got the then functions. Now the given receives a set of events and it just attaches it to the object here, the previous events. The when attaches the command, and the then is what kicks off the whole thing and returns this, this star testing callback function. This is what you needed. It returns that. It identifies itself as a test helper. If you didn't do this, whenever tests fail, it would show you the line. It would show you the line here instead of the over here, which isn't that great. But let's see. So the then section has to go and look and see what was the state of the system, or set up the state of the system the way that you expected in the given section. So we go to the previous events, which were passed in through the given function. And oh man, this is really hard to understand. So I go to the store and just save each one of those events effectively. And this stream previous event counts is a way for me to test whether, so say I have an event user was onboarded on the resource owner stream, that's event 0. When I go to the then, I want to go back to that stream and check what events have happened since that first one. I need to know how many were previously put on there so I can get all of the events from 1 forward instead of all of the events in the stream. That's what this stream previous event counts is for. It just counts all the events that I've saved to the stream previously. So we go through all of the previous events, we save them, then we call the dispatch method, and then now we go and build this expected event stream. The expected events comes from right here. You pass in all the expected events. For each one of the events, we go, let's see. The stream expected events is a map, taking the stream and just appending the events to that stream. Okay, that makes sense. Sorry, it's been a while since I've looked at this code. We go through each of the expected events for each stream, and we turn that event channel, we go to events by stream starting with, and this is a method that's on the event store. So this is the event store interface, and it's got all these methods. And there's a few implementations. There's an in-memory, there's a level DB, and then there's a failing event store for test purposes. If you wanted to have this store work with Postgres or MySQL, you could implement those pretty easily. I chose not to do that. Okay, so now we go get into the events starting with the event number that we expect, which comes from the previous stream event counts, right? And then there's the actual events. So we have the previous events in the stream and then the expected ones, and just see from the then section for each stream. Oh man, I'm kind of going in circles. Does that make sense? We're just checking to see that the events we expected for the stream actually are there, ignoring all the previous ones that were stored. That's pretty much it. There was another case I needed to have, which was I need to also inspect events, and this is a more advanced style. And what this does is it's a method that receives a list of events and then can take action and do some kind of procedural tests on them. I think I needed to do this to verify the password was set correctly. There wasn't a way for me to expect an event because the hash would change each time. Like the problem is, like if I just had then user was onboarded, and then let's fill the fields, user ID, email. Now this password hash, it's not going to be the same like that. Let's see, what can I do here? One more. If I run this event, this test, I know this isn't what you asked, but I wanted to call it out why I had this then inspect events issue, is that password hash changes every time. That's the whole point of a password hash. You can't, like right now, like it expected this hash, but we got this hash. Okay, well, let's take this hash and just put it in here.
So you could make it deterministic though, right?
Yeah,
Because
you could do like a seed, right? Like you can do, I don't know what I use for the hashing, but yeah, you could because
the hash should be the same from the same password. So you know, one of those things is, what do you for example, if you're signing up, it's legitimate for the command to have a clear password, because if you're not storing the command, or at least you'll scrub it if you do store it. The event actually contains the hashed value, right?
Right. Yeah. This is the event with the hashed value, but the way that taking the password that comes in on the command is the regular string, like the password. The process to turn that into this password hash, let's just go find where that happens. Oh, wow. Generate password hash. So whenever the onboard user command comes in, we emit user was onboarded, and we go generate a password hash.
Yeah.
And this uses bcrypt. It uses bcrypt to generate a hash for password.
Right. So this is one of the points that I make in CQRS event sourcing things, is do not have things that are invariants inside your state transitions, right? So I usually redo the problem where I'm injecting things like this internally somehow. Now this might be an exception, or it's just too convoluted to do it that way.
Right.
But the hash is based, usually gives you the same, I mean, it has to give you the same thing given the same password.
The way bcrypt does, it will not give you the same hash from the password. Every time you call it with a password, it since it's salted, it will give you a different hash every time. So that means you couldn't take a hash and get the password from it if you just did a dictionary attack.
Right. So you have to go a level deeper and control the salt.
Right. And
this is what I've usually done.
Yeah. But I found that if you had like a
so you normally use a doctor pattern for those type of systems. That's what event modeling would teach you. Like maybe you want.
Well, event modeling is agnostic again, but event sourcing definitely works a lot better when everything's deterministic and you bubble up anything that's like, for example, an exchange rate. If you're dealing with money, foreign exchange rates change. So what you would do is you would call out for the exchange rate and then insert that as a parameter on the command. From that point on, everything's an invariant. It's a functional paradigm at that point. And that's what you want if you can get it. Now, in this case, because of the implementation that's chosen here, maybe this is just too much work to do that. Right. But essentially, if I was to unwrap this and use some other scheme for hashing, I would get a level of command that would allow me to control the salt so that I could have it as one of the givens.
Got it. So for the most part, you're trying to shoot for deterministic events. And if you need to somehow rely on changing the implementation, then you bubble up the dependency as much
Always
as you can.
bubble them up. Absolutely.
Okay,
Make
cool.
everything as clean as possible. Your logic for your domain should be deterministic, so it's high quality. It doesn't have anything that depends on curveballs thrown from other implementations, other APIs, etc. Your product that you're building is rock solid. You know, if power goes out, that's the power company's problem or whoever didn't pay the bills, but your product works.
Got it. Yeah.
So I've been using kind of a like a job-like pattern for stuff like that. Is that kind of similar to what you're thinking here? You know, you're like, someone's like, go get me hash completed kind of pattern going on in there.
Are you talking about the implementation here?
No, it's more of if Adam's saying a similar thing to how I'm thinking, or whether I'm just assuming it maps onto what I was thinking.
It gets pretty hard to do that when you're talking about really old kind of procedural style code where a method can be 5,000 lines long and you have about 50 different nesting leveled statements in between if statements and case statements. So having to prep any possible value you're going to feed at those times is going to be next to impossible. Most likely you're going to have to break that up into some sort of a longer running kind of workflow, quote unquote, where you have intermittent read models, if you use the event model to show what you're doing, to stagger those points where it doesn't make sense to front load all the dependencies. Especially if there's a key decision in that logic based on a result of one of those things. However, when you can bubble them up, you do, and essentially those decision points that are made on the invariance in your business logic for an aggregate, let's say, that screams at you that this is where you're getting into trouble if you cannot bubble up that dependency. And this is where you should move it horizontally on the event model left and right to say, okay, whatever we get here, we dump into a read model of some sort, have a processor, have some other abstraction here to then continue off and fire off a second command that's got these things seeded. And this is how you linearize these disgusting tree-like proliferation of possibilities. Because usually when you're just doing that ignorantly, you're going to say, it doesn't matter what the if statement's about, it's just going to be another path. And that's horrible because you don't need to do that. A lot of these things are just done as mechanical things. They really truly do not depend on the absolute external dependency. And so you need to isolate those. And that should be the things that really slice up your event model at the very least. Anyway, that's just my experience. Hopefully that helps.
Yeah, no, it makes sense. Things can, you can take a function that's say like, too long, right? 100, 200 lines, as you said. There's like 5 or 6 if statements in there that are normally program flow just to smash out exceptions, or people think they're exceptions until they model them and then realize actually you want to do something off it. But that one function can then turn into like 5 or 6 process managers, right? Yeah,
exactly. I always favor string. Don't get you think you're getting some productivity by just shoving in yet another if statement, but in the end it becomes less and less clear as to what's going on. So you always draw those out horizontally so people understand what the hell this is. I'd rather have 50 smaller functions that I can describe on an event model. It takes a long time to go through, but that's okay because it's explicit and clear. You're not hiding complexity. And that's what's happening in these cases, is that people hide complexity, and that's when we get into trouble to make it the rising cost curves when there's maintenance and additional features trying to be added.
Yeah, cool.
John, did you have any other questions about this BDD style given when then harness?
No, man, I think it's really cool. I like how you got on that. Do you find that you're having to match on every field on every then, right, in that pattern? If you miss password off it, that would fail, right?
Right. It doesn't catch if you add a field. I don't know. I've had to add like scope to a few of these events because that's like an OAuth thing that you need to pass through. I'm not sure if I forget to add one that'll catch it. Might. But yeah, I don't think I would need to change it if all you cared about was the events and not the actual data on the events. For me, I really want to know that the event content is exactly the way I expect, because that's kind of important.
Key, right?
But yeah, is the refresh token there? Like, I need to know, especially if there's some type of flow that goes the refresh token on one stream matches the other stream, and it's kind of necessary.
Yeah.
How
No,
you
thanks very
know
much.
how you know the stream that you're supposed to subscribe to from the events? I missed that in the Go code.
Oh.
Like, were you actually doing the?
Yeah, I glossed over that. That's where some of the, I don't want to say magic, but that's where some of the code generation happens. You're asking in the then, how does it know which event, which
stream
stream
to subscribe to? Yeah.
Right. So this onboard user was rejected due to existing user.
Mm-hmm.
It implements the event interface, and the event type is on there, as well as an aggregate message, which has aggregate ID and aggregate type. Okay, with that being said, let's look at the methods on this thing.
So somewhere you're asking, hey, give me type, and then
Right.
in your database, get the stream by type.
Exactly. So what happens is this file only contains struct types that are events, and there's a go generate method that it runs this go event generator, and it puts it in the GoAuth2 package. It says the ID for each one of these is the user ID field, because this is the resource owner. The method will be event type. It's just a helper method that I wrote to generate this stuff. And then it generates these files on the right. So these three methods are implemented. It has an event type, which is user was onboarded. It has an aggregate type, which is resource owner, as well as aggregate ID, which is the user ID. Okay, now to answer your question for real, get event stream is what it does. So when I want the stream expected events, it takes in the expected events that you pass in, and for each one we get the event stream, and the event stream takes in this event, and the event stream calls message.aggregate type and message.aggregate ID. That's how we get the stream. And there's get stream method just formats it. In the implementation for RangeDB, it's separated by an exclamation point. I don't want to go into details about how it's organized, but that was the way to have a stream name. If you go to here, if you go to the UI for the data store, you'll notice that if you click on one of these aggregates, you go to the stream, and here is the stream. This is the resource owner with this ID and all of the events associated with the stream. If how can I get this? If we restart this and if you just copy all of these examples, it'll build up a system with the refresh tokens being used. Okay, now we got a bunch of events in the system. Let's go to the aggregates. So the resource owner has refresh token. This is the one we want to see. So the refresh token, if you look at the event number, it's 012, 012, 012. This event numbering is basically the version number for the stream, right? So those three events are on that stream. If you click on it, you only see the events for that stream, and that's pretty much it. What's interesting, a common question that comes up is, well, if you're having to replay events, wouldn't that be slower than having like a CRUD application? And I would say probably not, because with the CRUD application, you have to do joins. With the stream, you're just making a request for a bunch of rows of events, so it'll be pretty quick. You don't have to do that merging. So yeah, so this refresh token, looks like there's 3 different streams, because we did, what did we do? We got a resource owner password, we got the access token, and then we got a refresh token. And then we took that refresh token and got a new one using the refresh token grant. And there's the token we pass in. And then we got a new refresh token, made another request, just simulating the fact that this refresh token was used 2 times. And this third one, there's only 1 event because it was just issued and it hasn't been used yet. I know I went on a little bit of a tangent there. Did that help answer?
Yes, yes. That was why they asking the Slack of like, hey, could we just put kind of like it doesn't have to be hardcore specification you have to do about the book type of thing, but I just noticed that getting into this rabbit hole, I ended up in this databases concept of like getting by stream, getting by this type, and stuff like that. And then like, here we go. What should I do? Should I just use event store because I don't want to become an expert like that? Those type of details that eventually I would have to become an expert. So yeah, this is really helpful. especially knowing now that you have like a struct with all the specification of the stored. So yeah, that does totally make sense.
Cool. Now the version for OAuth2 project, it's I don't think I have released a version yet because it's not in a final state. If you go to this project, there's not a release yet, but RangeDB does have a release, and it's on version 0.2.6. So the implementation is going to change wildly until I get to version 1. I'm getting pretty close to being able to release version 1. That's probably maybe a month away. But if you're curious to use this, it's stable-ish. I don't think I could officially call RangeDB stable until at least 3 projects are using it. Right now, only one is this OAuth project, and it's not stable yet. So I can't call this data store stable yet. So I don't recommend using it at all. Use something else.
I mean, well, it's really good for academics for me, especially you decouple the interface to the actual database engine. I see that you have in memory stuff like that. So it's kind of like, it's the interface and also some implementation of that interface, right?
That's a great question. I'm really glad you asked because that's one of the better things about this.
Also, by the way, quick note, coming from Elixir, gosh, why Go people are so bad at writing documentation? It's like one line of like, no, put a paragraph there that explains everything about the functions.
You've been so spoiled with Elixir, man. It's amazing.
I am, because I don't know. That's something I struggle reading any Go documentation. It's kind of like, don't even write it. I don't need one sentence. Write a paragraph, explain to me.
Yeah, so this, if you want to write your own implementation of a backend, right now there's in-memory and there's a level DB store. Level DB is a key value, an incremental key value store, which means you can get the first, say you have a bunch of events that are based on a prefix of a key. You can get the first one and then iterate quickly through the other ones. And you can go in forward or reverse order. And that's really convenient because sometimes you need to get the version number for the stream, and you can just go to the last event in the stream really quickly. So there's a level DB store. If you do implement one, all you have to do is write a test and call this. I have a package called RangeDB test, and it has a verify store. And then you just pass in your store. So this one is an in-memory store, and you can call this verify store method, and it has a ton of tests. It tests all the different things, including all of the deadlock issues that I have fixed. They're all in here. I can just go like this. Oh, can I not? There we go. So we verify you can get all the events, effectively all the different use cases for the store. So yeah, this is all the tests you have to write, right? You just write this for your store, whatever dependencies your store needs. Like it may need a clock if you have to implement that. You'll probably need a serializer for JSON serialization, but yeah. Does that help?
That's cool.
Yes,
if you wanna,
this is some point.
if you want to do like Postgres, which I was planning on doing, I just don't have a reason to yet. That would be a good exercise to just try to implement a Postgres version.
I got it.
You've made a really interesting decision in your architecture.
Yeah.
I've built a couple, right? I've built an all stream and then span out projections into that and other events. I've built a ill-advised approach, which is split on every aggregate and have that in a separate file, right? Whereas you've gone for like aggregate and type in the same stream, right?
Yeah.
What made you want to do that? Because it's a really good idea.
Because I read a lot. I wanted to do this for projections. Someone had asked on a project we were working on, hey, I want to get all of the events, but only of this type. I don't need all of the events in the store because there's like millions of them. I only care about the few thousand that I care about. And then I looked, well, does Event Store support this? And I found a post that says, no, we don't. And then someone said, well, will you please do this? And they said, we closed it, said, no, we don't need to do that. You could just read all the events. And it was a challenge to me. How could I make it work where can you subscribe to an aggregate type? And I found out that's actually pretty simple with Level DB. Then it was like, well, what if you want to subscribe to 2 aggregate types and have them in order?
That's where you start getting into fun.
So
right?
I implemented that. And basically what I do in Go is just create 2. It's how the name came about, was RangeDB. I create 2 channels and range over each one of those things, and then put those into a structure, and then just get the one with the lowest value. It's probably not the fastest implementation yet, but it does what I want. I can subscribe to one or more. I can just show you real quick. We keep talking about it. I didn't think we were going to.
I don't want to drag this off because it's all recorded, and I'd love to chat to you about how you've written it, because it's turned into a hobby of mine, writing event stores, it seems.
Yeah, so if you go to the API, you can get all of the events. You can get them as JSON. You can get them as new line. I just typed it last time too. You can get them as new line delimited. So that's if you don't want to, if you don't have like a Sax parser, whatever. There's different ways you can get the events. But what you can also do is you can get them by stream. Like there's all the events for that stream. But you can also do, what's the other one? Refresh token. Say I want all of the events for resource owner and refresh token. Well, I think I can just do this. Is it slash or is it comma? It's comma. So this has all of the events that are, oops, resource owner. Those are the events, but also injected are the refresh token in their global sequence number, right? So if you look at global sequence number 0, 1, 2,
but
5.
Global sequence number, and hang on. So how are you doing that if you're saving these aggregates in different files?
Well, there's, I started with level DB, and it supports, the way I built it, it supports a way to, I don't know how to answer the question. I made it work.
It's just because you're not exposing that global number up to the client.
You are.
Okay, I haven't seen it today.
This isn't the event. This is the envelope for the event. The event is in this data, right? The event type is this, and that matches one-to-one to the struct. But there's also metadata on here. Like you could have your own metadata if you want. I think I had to have an epoch event that I added some metadata for granting user an administrator role. Like if you started up the OAuth server with no events in the system, you could never do anything useful with it because no one is an administrator. And in order to be an administrator, you have to have the role. So I have to like epoch this role in. And that's the only time I've ever used the explicit metadata part of RangeDB. But yeah, each record is what I'm calling the envelope, has a global sequence number and then a sequence number for this aggregate stream, for the stream. Yeah. But what's cool is you can just do comma and get all of the aggregate types you care about, and then you get all those, just those events. Like you get the refresh token events, you get the,
I quite like that. Yeah.
Good question, because I'm not familiar implementing this. So the sequence number is per aggregate type, and then the global number is in the entire system, right?
Yeah, the global number is all of the events in the store, and the sequence is for the stream specifically. We can have a separate conversation about how RangeDB works. Okay, we veered way off from process managers.
I'm thinking like ahead of like super performance problem.
Meetup. Should we schedule a follow-up meetup? We could do one on RangeDB. That would be kind of cool.
I totally didn't think that project was going to become anything. It was just.
No. Yes, awesome. It will. Yes, it will. Yeah. You made a mistake, sir. You put it out there. I'm sorry.
So let me know if you want to do it. I can use the Meetup again. I know it's not free, so I want to lend a hand and use this paid subscription thing, which is otherwise getting not used and wasted. So I'm more than happy to schedule anything you want and make you co-hosts.
Sure. There's some examples on the project if you're curious how it works.
Yes, I am.
So you go to RangeDB, and there's an examples link. And you can either go to the examples in GoDoc, which has, all this stuff, and then here's the output of what would happen if you work that way. So this is testing, getting all of the events. So you would create a new RangeDB API. You create a new server. You save some events to the server, and then you call get URL, which is getting all of the events. And then it does a JSON pretty print, and then here's what you would get back. It's effectively what you saw here, all of this stuff. And it's just asserting that it's basically, if you've ever seen how Go works, you can have a test that spits stuff to the standard out, and then assert that the output works. So it's a different way of writing a test using a main application.
That's really cool.
And it's really nice. I like it. Like,
it's an absolute bitch in .NET. Sorry, language.
Yeah, to do that, you prefix the function with example_, and then it just GoDoc knows how to read this and turn everything in the output section into what you saw over here. So it's a really nice way to demonstrate how this thing works. Let's see. So there's a WebSocket API as well as a regular API. So if you want to stream events, there's a way to do that. Yeah. So
stream events is kind of like a real-time like subscriber. Okay.
Yep.
Nice.
But if you have a projection that doesn't want to page through events, I think some of the other implementations have an Atom feed. If you just want to have like a real-time stream, you just get those, and it's really nice. I can't show you a video example of the first implementation of this. That's something that Alex and I made for a company that is closed sourced, but the RangeDB became open source whenever it wasn't used, and then completely rewritten. It wasn't, we didn't just take the code. I slowly built up and had slightly different implementation, but a lot of the same concepts.
Is there any differences? Because right now I'm studying a lot. Like I say, before I put any code down, I'm personally like to read a lot out there. So what is the big difference between this implementation and Event Store? Because I was looking the other day inside the code how they did it, and
I guess some differences I can point out is Event Store, the way they do projections is it's in JavaScript on the server, which is beautiful. I think that's really cool. I'd like to be able to do something like that with this, but I haven't gotten that far. Another difference is the primary backend database is LevelDB for this one. Though you could inject your own implementation of a backend if you wanted. I think that'd be just fine. I support getting events from multiple aggregate types, which is a pretty nice feature.
Yeah, that's cool.
But I mean, it's an event store. There's not a whole lot going on that's different. I think they focus more on event versioning. I didn't really put a lot of time into that, but I think it's still in there with the sequence number. I don't know, theirs is hardened. It's definitely more stable.
Right. Cool.
Yeah, Event Store does do event type and category, which is aggregate basically.
Is there anywhere you actually read about that type of specification, or is just by, I don't know, doing it so many times that you figured out how to do at least like a basic version of
RangeDB came from the project we were working on. We needed to build a proof of concept using event sourcing, and I made an in-memory event store and just a simple API to make requests. And then that grew. We needed WebSocket API, so I made a WebSocket one. And that's all we did. We had a project that just was projections, and that was it. And we didn't use the store, so I took it and made a LevelDB implementation and then released it. And
nice.
But the tests all use the in-memory version because going to disk would be a little bit slower. But there are it does execute on disk for the LevelDB implementation in the test. So just not the OAuth2. I'll use the in-memory version because it's faster.
Yep. We put Cassandra behind it, and voila, unlimited scalability. Nice.
Yeah.
Technically impossible.
Well,
yeah.
It's 3 o'clock. I don't think we should keep going. We can have a discussion about RangeDB in the future. Unless there's no more questions, I say we end it.
Yep.
Cool. Thanks Adam. Thanks, Alex, for being our host, and Adam as well.
Thank you very much. Sorry, it's taking a while to find the unmute button, but I'll forward this on to you as before, and let's get it out there for people to look, and I think it'll be really cool. I don't think this is the last one, so.
Cool. Well, thanks for
I'm looking forward to the next one. Yeah, thank you.
All right.
Bye-bye.